Hello, everyone. First of all, I would like to thank the organizers of this conference for providing me an opportunity to present my research work in 5th International Conference on Applied Zoology. The title of my presentation is The Bioprotection of Zea Maize from Aflatoxigenic Aspergillus flavus by Loigolactobacillus coroniformis BCH4. These are the outlines of my presentation. First of all, let me introduce the background of my research. The Zea maize is one of the most important cereal crop. It is also known as corn or maize and is most cultivated crop in the world. It is not only used as food, but also for animal feed and as raw material for the production of biofuels. It is the highest yielding among world's major crops due to its low cultivation cost. The Zea maize, it faces different infections, especially the fungal infection due to the presence of different fungal genera like Fusarium, Penicillium, Rhizopus, Aspergillus, and Titania during its germination, growth, and storage. Moreover, these pathogens also cause maize rot, kernel discoloration, loss of viability, mycotoxin contamination, and subsequent seedling blights. Deterrence of food from pathogenic microorganisms has always been a major task. The harmful products of such microorganisms is a major cause of risk for human as well as animal health. To overcome these risks, lactic acid bacteria have been used as bioprotective from few decades because of their safe nature. These labs produce various metabolites, including organic acids like lactic acid, acetic acid, and the phenyl lactate, bacteriocins antifungal peptides, luteins diacetyl fatty acids, and cyclic dipeptides, etc. These all secondary metabolites cumulatively influenced against fungal species as bioprotecting metabolites. The main objectives of my research is the in vitro biotic stress tolerance potential of Loigolactobacillus coroniformis BCH4 against Aspergillus flavus. Moreover, we also employed this effect for the bioprotection of Zea maize against A flavus. First of all, the methodology, we concluded the in vitro biotic stress tolerance of Loigolactobacillus coroniformis, and after evaluating this effect this potential, we employed this biotic stress tolerance against aflatoxigenic Aspergillus flavus. After concluding the biotic stress tolerance, we do fermentation production of antimicrobial compounds by using fermenter, and after fermentation production or after the production of metabolites, we do centrifugation for the collection of cell-free supernatant, and which was further filtered through 0.45 micron filters, and which was the filtrate was lyophilized and employed for bioprotective effect on maize grains. After that, the different treatments of maize grains were employed for FDIR to evaluate the functional groups of nutritional contents of maize grains, and also for the estimation of total phenolic flavonoid contents and antioxidant potential of maize grains, which was also followed by the determination of aflatoxins AFB1 and AFB2 by using HPLC. HPLC was also used for the detection of various phenolic acids in L. coroniformis BCH4 CFS. Now we come to the results. This is the biotic stress tolerance potential of Loigolactobacillus coroniformis and we can find out clear determination of zone of L. coroniformis BCH4 CFS against aspergillus flavus. That is the bioprotective effect of cell-free supernatant of Loigolactobacillus coroniformis BCH4 against A. flavus. These are the two treatments. One is B1 is the treatment of our maize grains with CFS of L. coroniformis, and A1 is the control, that is the treatment of maize grains only with MRS broth without any culture of L. coroniformis. This is the FTIR spectra of maize grains. First of all, I would like to tell that three treatments, that is the T1, T2, and T3. T1 is the raw maize grains. T2 is the MRS broth with A flavors that is used as control against our treatment. And T3 is the treatment of maize grains with A flavors plus the CFS of L. coroniformis, that is our targeted bacteria. And we found that the FTIR spectrum of T3 has an improved outcome of different stretchings that we can visualize here with a reddish brown shade. The stretchings of carbonyl, CH, OH, and NH improved in T3 treatment. Similarly, these are the phenolic flavonoid contents and antioxidant potential, and we can also visualize from these graphs. A represents the graphical representation of three treatments of phenolics. B is for flavonoids, and C is for antioxidant activity percentage. And here T3 has improved results in both in phenolics, flavonoids, and antioxidants. These are this one is the aflatoxins production determination, that is the AFB1 and AFB2 in different treatments. This one is a chromatogram of T1, that is the raw without any treatment, which we can compare with T2, that is the MRS broth plus A flavors treated maize grains that we used as control in comparison with our T3 treatment. We can visualize here the presence of AFB1 and AFB2, a considerable concentration of both these aflatoxins. When we compare this T2 with T3, we didn't found any considerable concentration of this AF B1 and B2 in our T3 treatment. So it was concluded that our collected CFS of L. coroniformis BCH4 has a strong anti-aflatoxigenic effect against A flavors. This last one is the detection of phenolic acids. We also concluded by our research that these resultant phenolic acids also participated in antifungal potential of CFS of L. coroniformis, and we found different phenolic acids like chlorogenic acid, p-cumaric acid, 4-hydroxybenzoic acid, cafeteric, synapic, salicylic acid, and benzoic acid. This is the resultant chromatogram of phenolic acid detection by HPLC. Now I would like to conclude my research work. The present work represented the Loigolactobacillus coroniformis BCH4 could be a good biotic stress tolerant bacterium. It was observed that L. coroniformis CFS has strong anti-aflatoxigenic potential against A flavors on maize grains. The current findings also highlight higher nutritional total phenolic, flavonoid, and antioxidant contents in CFS treated maize grains in comparison with raw or A flavors infected grains. Moreover, this resultant biocontrol agent could also be used to improve the nutritional values and shelf life of other cereal grains that we will inshallah do in the future. The details characterization of this bacterium will be helpful as biocontrol agent and to explore its other beneficial effects in the future that we are also working on these aspects. And thank you so much for your attention. Thank you.